Hello, I'm Ben Wood and this is a video of the solutions to the question set 12. The first question that we're given is to find the value of t, when t is given by this expression. The first thing that we should look at is the 16 to the power of 3 over 2. We know that this means to square root and then cube the answer, so the square root of 16 to the power of 3 is 4 to the power of 3, which is 64. But the value that we need to know is this number's square root, and the square root of 64 is 8. We can then work out that the first part of the expression is 48 over 8, which gives 6. Moving over to the right-hand side of the expression, if we take a look at 3 to the half first, we know that this means the square root of 3. Putting that figure aside, let's take a look at the bracketed part of the expression. It should jump out to you straight away that the square root of 4 is 2, so the fraction can be simplified down to 4 plus 2 over 2, which is 6 over 2, which is 3. So the value of the bracket is the square root of 3. So we have that the original expression can be written as 6 minus the square root of 3 times the square root of 3, which, using the laws of indices, gives just a value of 3. So the entire expression can be simplified down to 6 minus 3, which means that t is equal to 3. Question 2 gives us two cylinders, which I've named C1 and C2. The cylinder C1 has radius 4 cm and height t plus 6 cm. The cylinder C2 has radius 4 plus y cm and height t minus 2 cm. We are told that the volumes of both of the cylinders are equal, and we need to work out the values of y. The first thing that we're going to look at is the volume of C1. We know that the volume of a cylinder is given by pi r squared h, which in this case is pi times 4 squared times t plus 6, but since t equals 3 from question 1, t plus 6 is simply 9 centimeters. So the volume is actually pi times 16 times 9, which is 144 pi centimeters cubed. Taking a look at the volume of C2 separately, we can use the formula pi r squared h to work out that the volume is pi times 4 plus y squared times t minus 2. But again, since t equals 3, we can replace this last value with 1. So we get that the volume is pi times 4 plus y squared centimeters cubed. Now, since the two volumes are equal, we can set the two results that we attain to be equal to each other. So 144 pi equals pi times 4 plus y squared. The first thing that we want to do is divide both sides of the equation by pi, giving us 144 equals 4 plus y squared. Now, if we take the square root of both sides, we get that 12 equals 4 plus y. Finally, if we take 4 from both sides of the equation, we get that y equals 8 centimeters. Now for question 3. Don't forget that y equals 8 from the previous question. We are given the following set of equations, and we need to find a value for c. The first thing that we're going to do is replace y in the question with 8, which gives the first equation to be 24c plus 7d equals 4. Now, if we rearrange the second equation, we can get the value of d to be 20 minus e by subtracting e from both sides. If we substitute this value of d into equation 1, we get 24c plus 7 times d, which is 20 minus e, to be equal to 4. So 24c plus 140 minus 7e equals 4. If we take 140 from both sides, we get that 24c minus 7e equals minus 136. Next, we're going to rearrange equation 3 to get a value of e. If we take f from both sides, we get that e equals 36 minus f, which we can then resubstitute into equation 1 to get 24c minus 7 times e, which is 36 minus f equals minus 136, which gives 24c minus 252 plus 7f equals minus 136. Adding 252 to both sides, we get 24c plus 7f equals 116. For the final rearrangement, we need to make f the subject of the fourth equation, so taking 5c from both sides we get f to be equal to 15 minus 5c, We can substitute this into the first equation, for the last time, to give 24c plus 7 times f, which is 15 minus 5c, equals 116. So 24c plus 105 minus 35c equals 116. Taking 105 from each side and combining the elements containing c, we get that minus 11c equals 11. Finally, if we divide both sides by minus 11, we get the final answer that c equals minus 1. The fourth and final question shows us a diagram of three triangles touching corner to corner. We are asked to work out the value of x. Remembering that c equals 1 from question 3, the first thing we're going to do is replace all of the angles containing c with minus 1. Doing this gives us this diagram. To work out the value of x, we're going to use two basic rules of angles. The first rule that we're going to use is that all angles in a triangle add up to 180 degrees. So we can take the triangle on the left and name the missing angle to be 180 minus 7x. The other rule that we're going to use is that opposite angles on a cross are equal. We can use this to label the middle triangle in the following way. The remaining angle in this triangle we'll call beta, and it can be worked out in a similar way as before. It is 180 minus 7x add 5x, which simplifies down to just 2x. On the diagram, this looks like this. Then, again using the rule that opposite angles on a cross are equal, we can amend the last triangle using the 2x from before. Then, using a final application of the sum of the angles rule, we get that 180 equals 2x plus 7x plus 6x. Taking a factor of x, we get that 180 equals x times 2 plus 7 plus 6, which is just 15x. So if we divide both sides by 15, we get that x equals 12. So the final result that we get is 12.